In this video, we're going to be graphing rational functions. We're going to do constant over linear, which is just a number in the numerator, and then a variable in the denominator, and then we'll do linear over linear, which is variables in both the numerator and the denominator. Okay, so to do this, we have 5 steps. We want to find the vertical asymptotes, find the horizontal asymptotes, find the x-intercepts by setting the numerator equal to 0, and find the y-intercept by setting x equal to 0. If you aren't familiar with how to find vertical and horizontal asymptotes and you want a little practice on that, I will link a video in the description that will lead to the video on asymptotes so you can get a refresher on that. Okay, so let's look at the first one. First thing we want to do is find the vertical asymptote. That means set the denominator equal to 0 and solve. So that's x equals 2. Okay, so we'll go over here to 2. We'll put a little dotted line right here at 2. Okay, horizontal asymptotes, it's Bobo, Botten, eats DC. So bigger on bottom is the one we're using because the exponent is bigger on bottom. It's an exponent of 1, and there's no x term on top at all, so the exponent on bottom is bigger. So your answer is going to be y equals 0. Again, if you need a refresher on that, go to that other video. So this is just more of a guideline. Sometimes you can cross this line, this horizontal asymptote, but you can never cross a vertical asymptote. Okay, because doing so means that you made the denominator equal to 0, which you can't do. It has no solution. So you will never cross a vertical asymptote, but you can sometimes cross a horizontal asymptote. What the horizontal asymptote does is sort of guide the graph as you go out to infinity. And as you go out either direction, the graph, either if it's coming from the top and bottom, will get closer and closer to this line on either direction. Okay. So x-intercepts make y equals make the numerator equal 0, excuse me. So I set 4 equal to 0, which of course has no solution because we don't have a variable there. So no, we'll say that there's none on the x-intercepts. Y-intercepts, we'll let x equal 0 and solve for y. I'm going to replace the f of x with a y. Y is equal to 4 times 0 minus 2, and that ends up being negative 2. So at y is equal to negative 2, we cross the y-axis. It's going to be right there. Okay, and now we need to come up with some other points. Okay, so we need to pick some points that are over here on the left of this vertical asymptote and some points that are over here to the right of the vertical asymptote. Okay, so let's choose x equals 1. So that's this right here. So if I make x equals 1, then I have y is equal to 4 over 1 minus 2. And that's going to be negative 4. So I get the point 1 comma negative 4. So 1 on the x, negative 4 on the y is right there. Let's do another one. Let's go over here to say negative 1. So x is equal to negative 1. So that gives us y is equal to 4 over negative 1 minus 2. Might have been better to do negative 2 because it would have worked out nicer. But this is going to be negative 4/3. So that's going to be the point negative 1 and then negative 4/3, which is just a little bit more than negative 1. So we go to negative 1 on the x-axis, and we go down to negative 4/3, which is right here. We could plug in one more. If we plugged in x equals negative 2, that would make the denominator equal to negative 4. Okay, so 4 over negative 4 would be negative 1. So I'm just going to pop that point in there as well. So we can sort of see what that graph, that's how the graph's doing. It's getting closer to this line, and it's also getting closer and closer to this line. Okay, so there's that portion of the graph. Now let's look at the other portion. So let's plug in some numbers over here on the other side of this vertical asymptote. Let's try x equals 3. We plug in an x equals 3, and we get y is equal to 4 over 3 minus 2, and that's going to be equal to 4, because 3 minus 2 is 1. Okay, so you get the point 3 comma 4. 3 comma 4 right here. Okay, let's do 4. So x equals 4. We get y is equal to 4 over 4 minus 2, and that's going to be 4 over 2, which is 2. So that's the point 4 comma 2. 4 comma 2. And we can assume that the graph is going to look kind of like the other side. So we can go ahead and sketch this graph right here, and it's going to look something like this as it goes, and it will brush up against that line there. Okay, let's take a look at this problem. We have f of x equals 2x plus 6 over x plus 4. Okay, so the vertical asymptote, we set the denominator equal to 0. So that would be x plus 4 equals 0. That's x equals negative 4. Okay, so our vertical asymptote is at negative 4. So I'll put that little dotted line right here. Okay, and then for the horizontal asymptotes, it looks like the exponents on top and bottom are the same. So we're going to divide the leading coefficients. That's a 2, and that's a 1. So it's y equals 2 over 1, which is, of course, just y equals 2. Okay, so our horizontal asymptote's at 2. Okay, so there's kind of our new little grid there. All right, so to find the x-intercepts, we set the numerator equal to 0. So 2x plus 6 equals 0. 2x equals negative 6. X is equal to negative 3. Okay, so our x-intercept's negative 3. That's right here. So it looks like this portion of the graph is going to be down here. Probably the other portion is going to be over here, but we'll find out soon enough. Y-intercept, for the y-intercept, we let x equal 0. So it'll be y is equal to 2 times 0 plus 6, and then 0 plus 4. Of course, these two terms go away. It's 6 over 4, which is 3 over 2. Okay, so our y-intercept is 3 over 2, which is about 1.5. 1.5 is about right there. Okay, so that gives us a pretty good idea what this is going to look like. Should fall something like that. We can plug in some more points. Let's plug in one more point over here on the right side. Let's plug in, say, a negative 1. Actually, let's do negative 2. So I'll plug in x equals negative 2 into the function. So that's going to be f of negative 2 is equal to 2 times negative 2 plus 6 over 2 plus 4. So let's see, that's negative 4 plus 6. The top is a 2, the bottom is a 6, so that's 1/3. Okay, so at negative 2, we get 1/3, which is about, here's 0, 0. 1/3 is just a little bit up. So we go over here to negative 2, and we put a point like right there. Okay. Looks like I made a slight error there. I accidentally put a 2 here. Let's make that negative 2 because that's what we were plugging in. So that's going to change the answer. It's not 1/3. It didn't look right anyways. So it's going to be, let's see, the top is still a 2, and the bottom is also going to be 2, so that's 1. Okay, that makes more sense. So forget that point. It's going to be right here at negative 2, 1. Okay, so this side of the graph is going to look like this. Okay. All right, let's plug in some points over here. We have like maybe negative 5, negative 6. We can plug those both in and see what we get. Okay, so let's plug in x equals negative 5. So that will be f of negative 5 is 2 times negative 5 plus 6 divided by negative 5 plus 4. Okay, so the top turns, that's negative 10 plus 6 is negative 4, and the bottom turns into a negative 1, so that's 4. So we get negative 5, 4. So negative 5, we go up to 4, and we put a point. Negative 5, 4. Okay, let's do one more. Let's do the 6. Okay, so x equals negative 6. So that's f of negative 6, which is going to be equal to 2 times negative 6 plus 6 over negative 6 plus 4. Okay, so let's see, this turns into a negative 12. Add a 6, that's a negative 6. And the bottom is a negative 2, so that's going to be 3. So that gives us the point negative 6, comma 3. Negative 6, comma 3 is right here. Okay, so that gives us a pretty good idea that the graph is going to look like that. And it probably won't cross this line, so it'll probably go a little more steady out there than that.